Okay, so what we want to do in this video is look at some examples of the chain rule and see how we can tackle some of these types of problems. So I have three of them and what we're going to do here. So let's start with A. So I'm going to write it here, A. So I'm going to write it in a special way that'll make it much easier for us to look at. Okay, right here, sine of 3x plus 1, and we want to find its derivative. The way we would look at this is the chain rule basically says if you have something in the inside of a bigger function on the outside, you can take the derivative of the inside and some of the outside and have it through this formula. So f of, let's say, g of x, right? This is what the chain rule says. If you want to find its derivative, this is the formula right here. Well, let's find what the inside is. The inside is 3x plus 1, right? And the outside is just sine, right? What we want to do is find its derivative, which is g prime of x is 3 and f prime of x is cosine. So we found all the parts, now we just have to put them all together. So here I'm going to put it down a little bit. So it's cosine of, we have to keep the inside the same, and then we multiply by the chain, which is 3. And then we can just like make it look nicer if we want. And it's this, right? So just a little recap. I wanted to know what the inside was, and then I wanted to know what the outside was, which was sine. Sine was the outside function, and then 3x plus 1 was the inside. I found the derivative of each here, right here and here, and then I just put together all the pieces. I needed to know this one, this piece, and this piece, these three pieces. And then I just put them together. So remember to keep the inside function the same, but then and then you multiply by the derivative of the inside at the end. So let's look at B. So let's see. This is B. B was saying, let me just go back up and see what they were asking for. B was saying, okay, y is equal to sine, or no, it was the other way around. Cosine of sine of x. Pretty sure. Yep. So here, let me just scroll down here. Make this look like this. So then we can find the inside and the outside, right? So the inside would be sine, so this is our g of x. And our outside is our f of x, which is cosine. You can find the derivatives pretty easily, right? G prime of x is equal to cosine, and then f prime of x is equal to negative sine. So now we just combine them into the formula for the chain rule. I'll just keep rewriting it every single problem so that you'll remember this better. So it's negative sine of whatever's on the inside, which is sine. Remember to keep the g of x, or the inner function, the same first, and then you multiply by its derivative. And then we're done. That's that problem. It's pretty simple. Just the hard part is finding what is exactly the inside and what is exactly the what exactly is the outside. So part C was y equals tangent of, and then I'll just write it in the same color. Alright, you know what the inside function is. The inside function is 2 over x, right? That's our g of x. And then our outside function, therefore, should be tangent. We can find the derivative of the inside function by using the power rule. I'll show you it in steps. You can probably do it in your head maybe, but it's 2x minus 1, right? So this is what it is, and then so its derivative should just be, you bring the 1 over and then you subtract, which is this, right? This goes to this, and then we get the answer of negative 2 over x squared. The derivative of tangent is secant squared. This one you just have to know by memory. And then now we can find what y prime is, right? Y prime is just the derivative of the outside, secant squared, of whatever it was on the inside, keep it the same, but then you want to multiply by the chain, which is this. And then I guess make it look nicer. So we just did about 3 problems of dealing with the chain rule. Let me just zoom out. So basically the key takeaway here is to figure out which one is the inside function and which one's the outside. And remember that you want to keep the inside here, you want to keep the inside the same here but not here. This is the derivative, this is not the derivative. But you are taking the derivative of f, but whatever's inside of f prime is the same, except for when you multiply it by the end.